Hey guys, and welcome back to another video on the channel. Today's pretty much a part 2 for the arithmetic series video. So we already uploaded the first part where we took a look at these questions here, and now we're pretty much just running through the second part where we're going through the last example and then some actual questions from the math method syllabus, one of the textbooks I've chosen from. If you actually want to know where all these questions are from, I chose it from the Cambridge version, but I'll probably do follow-up videos where I do other questions from different books because the syllabus isn't tailored just to one textbook. There's tons of textbooks tailored to the Queensland syllabus. So let's just get straight into it anyway. So the sum of the first 10 terms in an arithmetic sequence is 48 and 3/4. If the fourth term is 3 and 3/4, find the first and the common difference. So in other words, we're told, all right, the sum up until 10 is 48 plus 3 on 4, pretty much. What else we're told? We're told the fourth term is 3 plus 3 on 4, otherwise. And we're asked to find the first term, so T of 1, and the common difference. Okay, so let's see what we have straight away. So let's write out both formulas. So S of n, your sum, n over 2, twice the first term, plus n minus 1 times by d. So that's your first pretty much formula for a sum up until n. And then we've got our normal arithmetic sequence formula. So T of 1 plus n minus 1 times d. Okay, so if we plug in our stuff at the moment, we can change our indexes for a couple of things. So for example, if I plug this into here, wherever the n appears, I can replace with a 10. So if I plug that into there, I'll go, all right, S of 10 is equal to pretty much 10 on 2 on t, 2 times T of 1 plus 10 minus 1 times by d. Here I can also plug in this index. So for example, if I plug in the fourth term, wherever there's an n, I can replace with a 4. So I can go, alright, T of 4 is T of 1 plus 4 minus 1 times by d. At the moment, I can see we're going to get two simultaneous equations with two unknowns pretty much. So if I plug this guy here now, I'm going to get an equation with T1 and d, and then if I plug this guy into here, I'll get another equation in terms of T1 and d. So all I'm going to do is plug that in, but I'm actually going to change how this looks at the moment. So I want to pretty much combine this because I don't like how it looks at the moment, and I don't like how they're written in the question at the moment. So the way you can combine things is you need to have a pretty much a common denominator. So we need to put 48 over a denominator of 4. So in other words, you need times 48 by 4. So 48 by 4. And if we do, actually we'll do a little multiplication table over here. 4 times 8 is going to be 24. 4 times 4 is 16 plus 8 is 18. So 184 is 48. And if you were to double check that, if 184 divided by 4, it should give you, actually no, that's incorrect. Let me just double check that. No, that's not correct. 48 times by 4. 4 times by 8, yeah, is going to be 32. Sorry, my mistake. I just realized I put 24 there. 4 times by 4 is 16. Plus 3 is going to be 19. So 92 on 4 should be 48. My mistake there, guys. Sorry about that. So that'll be 48. And then if you plus 3 on 4, like we have over here, pretty much, all you gotta do is just add the stuff to the top. So you have 95 on 4. So I'm just going to replace that with 95 on 4. And if you were to double check in your calculator, if you were to double check that, it would give you 48.75, which is 48 and 3/4 pretty much. Okay, I'm going to do the same thing here, but this one's a bit easier because it's just 3. But who knows, I could stuff it up because I did stuff up that little basic thing just there. But otherwise, you will have to do stuff like this if it's in non-calc. It just makes things a little bit easier dealing with a fraction rather than a weird thing like that. So 12 on 4 is the same as 3. So plus 3 on 4 plus 3 on 4. It's going to give you 15 on 4. And if you were to double check that, that will give you 3.75 roughly, or it should do. So 15 on 4. So now I'm going to replace those numbers in there. So I'll get 195 over 4 gives me 10 divided by 2 is 5. 2 times by t of 1 plus 9d. Then I'm going to have 15 over 4 equals t of 1 plus 3d. Now, it doesn't matter which one you pick to make the subject, pretty much, but one will be significantly easier than the other. So at the moment, let's just rub this stuff out, and we pretty much have two equations. Now, the equation on the right looks a lot easier to make one the subject than the one on the left, purely because the one on the left has a lot more numbers and has a 5 out the front. So we're going to be looking at the equation on the right to pretty much make one in terms of the other. So the easiest thing to do at the moment is actually just to make t1 the subject, because all I have to do is just move the 3d to the other side. If I were to make d the subject, I would have to move this guy to the side and divide by 3, but here I can just move this guy to the other side. So t of 1 is 15 on 4 minus 3d. Now I can actually just plug that wherever t of 1 is, and then I've got an equation in terms of d. So I've got 195 over 4. I'm going to move the 4 up there just to make it a bit easier. So of 195, 4 times 5 is 20. 20. Then 2 times 15 over 4 minus 3d plus 9d brackets. Okay. So at the moment, things look a bit rough at the moment, but there's not much we can really do about it. What we're going to do is pretty much just apply a lot of algebra and stuff. Now, let's just distribute this, because why not? We can. So I have 195 equals 40 times by 15 on 4 minus 3 on d, plus 20 times by 9 will be 180, because 2 times by 9 is 18. Add in that extra 10 factor. Alright, and then we apply the stuff in here. Now, the reason why I'm doing this without a calculator at the moment is because math methods, the content is relatively hard, but the hardest stuff is doing stuff like this. The stuff without the calculator, the stuff you're taught all the way through school pretty much. Just little stuff like the expanding brackets, because this is where all the silly mistakes are pretty much made. So by doing this question a bit slower than usual, it's actually improving your algebra just by watching me manipulate a lot of things like this. Okay, so I know 40, if I divide that by 4 will give me 10. So I'll have pretty much 40 over 4 times by 15. I know that's going to be 10. So I have 10 times by 15, which is 150. So 150 minus 3 times by 40d. So all I've done is distribute that, plus your 180d, okay? And that's still equal to 195. So if you don't know why I just did that, all I did was expand the 40 to this term and this term to give me that 150, and my 3 times by 40d, pretty much. I can actually move these brackets now because I don't need them, because there's nothing being multiplied anymore. This is still equal to 195, by the way. Okay. So 3 times by 40 is going to be 120. So 150 minus 120d plus 180d. Now we can add these two together. So what we're going to get is, this is still equal to 195. So 195 equals 150. Negative 120 plus 180 is going to be positive 60d. Now I move the 150 to the other side. So 195 minus 150 gives you 60d. 195 minus 150, I believe, will be 45. Yeah, 45. Equals 60d, okay? Now, we see our common difference isn't going to be a whole number straight away, okay? So, and I was kind of expecting this because of the terms we have here, because your first term is a weird fraction. It's 15 over 4, for God's sake. And this one here is, yeah, another weird term. So, we don't really have any, like, specific things here that are whole numbers. So, I'm expecting a value of d that isn't like fantastic. So we have 45 divided by 60 gives you d, okay? You can try and simplify this if you want. We can actually try that if we really want to here. So if we move that up there. So we've got to think of things that multiply that they have in common. So for starters, 15 times by 3 is 45. 3 3 times by 20 is 60, so straight away we can cancel out those 3's. So now we have 15 over 20, which I believe can be simplified even further, which will be 3 on 4, because 15 is the same as 5 times by 3, and 20 is the same as 5 times by 4. So yep, our difference we should get is 3 on 4. Righto, so now we've found our difference. All we do is plug this guy back into here pretty much, and it gives you your T1 term. So notice we did all that without a calculator. Most of it was just arithmetic and manipulation of numbers. And that's probably the hardest part about math methods, doing stuff like that, with combining with new stuff you've probably never seen before. Okay, so for the rest of the video I'll probably use my calculator though, just otherwise this video is going to be very, very long. So T1 is 15 on 4 minus 3 times by 3 on 4. Okay, so what we're going to have is T1 is 15 on 4. 3 times those 3 is 9, so minus 9 on 4. So what we're going to get is pretty much 15 minus 9, which is going to be 6 on 4. So your first term is 6 on 4, which is 3 on 2. So T1 is 3 on 2. And your difference is that. Now, what I'm going to do now is I'm going to double check these are correct. And the way I can do that is, alright, if I don't get the information I've been given the question with these answers, then I've made an error pretty much. So in other words, let's prove that the 10th term is, what was it, 195 on 4? I believe that was it. I'll double check actually real quick. Yeah, that'll be it. So if the sum of the first 10 terms isn't this number, then we've made an error. So S of n is n on 2 twice the first term plus n minus 1 times by d. I'm going to plug all this information in, and as index equals 10 pretty much. So S of 10, we're going to have 10 over 2, 2 times by 3 on 2 plus 10 minus 1 times by 3 on 4. Okay, so S of 10, 5 times by, that'll cancel, so you get 3. And then we have 9 times by 3 on 4. 3 times by 9 is 27, so you're going to have 27 on 4 there. So you're going to have plus 27 on 4. So if this doesn't turn out to be this, we've made a significant error. So what we have here is, alright, the first term is 15, plus, alright, 5 times by 27. We can work that out using a multiplication table. So 5 times by 7 is 35. 5 times by 2 is 10, plus is 13, so 135 on 4. Okay, this is kind of looking promising at the moment. So S of 10 is 15 plus 135 on 4. I'm going to rub this stuff out now, just so I have enough room. So the way we're going to add them together is we need a common denominator. So in other words, we need pretty much, alright, 15 times by 4, divide by 4. 15 times by 4 is going to be 60. So what we have pretty much is 60 plus 135 over 4, which gives us 195 on 4, which is what we had here. So that term has been proven correct. And now we want to check the fourth term is this. So that I believe was 15 over 4. I'll double check that as well real quick. Yep. So T of n equals T of 1 plus n minus 1 times by d. So then for T of 4, plug in your first term, which is 3 on 2, plus 4 minus 1 times by 3 on 4. So what we're going to have is pretty much, alright, 9 on 4. 9 on 4 plus 3 on 2. So in other words, we're going to have 9 on 4 plus 6 on 4. So in other words, we get 15 on 4, which is correct as well. So that means both of these numbers are correct. We found the correct ones. Okay. Now that took 14 minutes with this example, but I think it was a very good example to go through. And there'll be plenty more questions in the video. Trust me, I've got a couple here to go through. Anyway, let's move on to the next one now. So a lot of these is just pretty much plug and sub, pretty much. So you plug in pretty much this information to the formula with this information, and you work out what this is pretty much. So the first one, we're just pretty much plugging into the same formula. So S of n on 2, twice the first term, plus n minus 1 times by d. So first one, you're looking for your 12, the sum of your first 12 terms. Your first term, t of 1 is 8, and this is how much that's increasing by. So it's going from 8 to 13, so your difference is 5, and you can double check that there as well. So 13 to 18 is also 5. So shove in these numbers, so replace wherever the n is with 12, so 12 on 2, 2 times by 8, plus 12 minus 1 times by 5, and let's try and work out what this will be. So this front bit will be 6, this will be 16, this will be plus 55, because 12 minus 1 is 11, times by 5 is 55. 16 plus 55, oh, that's a tricky one, 71, I think. Yep, so 71 times by 6, 6, and then 7 times by 6, I believe, is 42. So the sum of the first 12 terms is 426. I'll write that there. And that's how you work at that first one. And you do the same with each of them. Now I'm going to do every single one here because there's only 3 more to do, and it's my video, and I think you benefit from seeing a couple examples, not just one. That's a relatively easy example. Like the rest of them look a bit funny because I've got fractions and this one has decimals. So this one here, looking for the 10th term, so I'm going to just write this formula in the corner here just so I don't have to do it a couple times. So your first term is negative 3.5. Now let's see if we can actually write that as a fraction. So in other words, we've got negative 3 minus a half. Okay, so if you add those two together, you get pretty much that. So negative 3 is the same as 6 on 2, negative 6 on 2. So in other words, we've got negative 6 on 2 minus a half. So in other words, negative 7 on 2. So if you were to double check that in your calculator as well, you'll see negative 3.5 is actually negative 7 on 2. So we've got, alright, negative 7 on 2. Then we've got negative 1.5, I know for a fact is negative 3 over 2. So we've got negative 3 on 2. So we can always see there's a pattern starting to appear here. And then finally we've got positive a half. So I've written all these guys in terms of fraction form. So the pattern is, well, it can be obvious in both cases, but for the algebra part, it's going to be much easier to evaluate. So move that there and move this stuff up really quickly. So your first term is negative 7 on 2. Now let's see how much, we can see it's increasing, but by what amount? So it's going from pretty much here to here, so we can see it's actually increasing by, I believe, positive 2, and same here, it's increasing by positive 2. So t of 1 is negative 7 on 2, and your difference is 2. Now the reason I converted to fractions mainly is because when we plug into this formula here, the algebra will be a lot easier to deal with than dealing with the decimal version. So S of 10, is 10 on 2. Times by 2 times by the first term, which is negative 7 on 2. So for example, stuff like this is very nice. Those 2's can cancel out. Plus 10 minus 1 multiplied by 2. So what we have is pretty much 5. Those cancel, so we get negative 7. And that turns into 9 times by 2 plus 18. Now, some of the first 10 terms, it isn't going to be a big number, mainly because the third term is a half, and it's only increasing by 2, so it's not going to be that big. It won't be in the hundreds like this one is, so I'm not expecting a huge number, and we can see algebraically we're not going to get a big number. 5 times by 7 is negative 35, and then 5 times by 18, or 5 times by 18, that's going to be 40, and then 5, and then plus that is 90, so plus 90 minus 35, I believe 55. Yeah, so yeah, that's about what I was expecting. So the sum of the first 10 terms in that arithmetic sequence is 55. Right, so let's rub this stuff out and let's continue with these other guys. So a lot of these are the same pretty much questions, but these are questions you kind of have to do if you want to get really good at these, because yeah, they might be easy, but you might forget how to do it if you don't do enough of them. So doing like 4 like this, or maybe even 6 or a bit more, is very good for practicing. So your first term in this one is a half. Your difference is positive a half. And literally just plug into this formula again. So replace the index with 15, so S of 15, and wherever there's an N you put a 15. 2 times by the first term plus 15 minus 1 times by the difference. So I don't know what 15 over 2 is, I think it's 7.5, but I'm going to leave it like that for now. That can cancel. That's going to be 14 over 2, which turns into 7. So in other words, we've got 15 over 2 plus 15 over 2 times by 7. So at the moment we've got some stuff here we need to do. 15 times by 7, 35. 7 and then 10, 105. So you get 105 over 2 plus 15 over 2. Now you can actually just add those together and you'll get 120 over 2, which is 60. So your sum of your first 15 terms is 60 here, which makes sense because they're all positive numbers and that's a lot of terms you're adding up. So that's what I'm about expecting as well there. Okay, so last question for this little batch here, then we'll move on to some worded questions, which are more likely test questions, but you still could get ones like this. It's literally the same stuff. All they do is just add in a couple of fancy words straight away. Okay, so your first term here is -4. Now we can see it's increasing, but it's increased by +5. And we can see it's also increased here by +5. So your difference is +5. And up until 8. So S of n is n over 2. 2 times t of 1 plus n minus 1 times by d. So replace the index with 8 equals 8 on 2. 2 times by the first term, which is -4, plus 8 minus 1 times by 5. And let's try and work this out. So the first bit here is going to turn into 4. This is going to be -8. This one's going to be 7 times by 5, which is +35. 35 minus 8 is going to be 27. So you have 27 times by 4, which we can work out right here with a multiplication table. 4 times by 7 is 28. Then 4 times by 2 is 8, plus 2 is 10, so 108. So that will be, your first will be 108. Ta-da! Alright, those are all those ones done. Let's move on to the next question, because those ones are very boring, but they're necessary to do well at this topic pretty much, because it's just practice. Right, so question 4 that I've chosen. So Greg goes fishing every day for a week. On the first day, he catches 7 fish. 7 fish, sorry. And each day he catches 3 more than the previous day. How many fish did he catch in total? So straight away, your first term is 7 fish. So t of 1 is 7. And you'd actually told the difference. Each day he catches 3 more. So your difference is +3. Now, how many days are in a week? There's 7. So when they ask how many fish did he catch in total in the total week, you're asking for S of 7 pretty much, because there's 7 days in a week. So S of n is n over 2, 2 times the first term, plus n minus 1 times by d. Then you plug in 7, where the index is, so 7 on 2, 2 times by 7, plus 7 minus 1 times by 3, and let's see what we get. So 7 on 2, and then you're going to have pretty much, well, we can leave this, we can cancel that with that. Oh, actually no, because we've got to apply to everything straight away. My mistake. So if I apply this to here and to here, let's see what we get. So the first bit, you're going to get pretty much 7 times 7, because the 2's will cancel out, because that's a divide by 2 and that's a times by 2, so you get 49. Then 7 on 2. Now this bit's going to be 6 times by 8, which is 18 times by 7 on 2, which is pretty much 9 times by 7, because 18 divided by 2 is 9, so 9 times by 7 I think is 63. So what you're going to get pretty much is 49 plus 63. So if you add those two together, that will give you your sum. So in total, he caught a, wow, that is a lot of fish. I wonder if we did our math right. 112 fish. Let's think about it. Okay, so 7, 10, 13, 16, 18, so that's 5, plus another 3, 21, plus another 3, 24, 1, 2, 3, 4, 5, 6, 7. Okay, I don't know. Oh, does that equal 112? I'm just going to double check that really quickly. So this is another way you can do it, the old-fashioned way if you really want to check. But I'm just going to check it because that's a lot of fish. And I haven't done these questions. I'm just doing them raw pretty much, because that's how most students will do it. 109. Okay, so we've made an error somewhere. Actually, did I add those all correctly? On the first day, he catches 7 fish, and each day he catches 3 more than the previous day. Yep. Okay, so we've made an error with our algebra somewhere here. So let's double check for that. So the difference is still positive 3. So S of n is n on 2, 2 times by t of 1 plus n minus 1 times by d. S of 7, 7 on 2, 2 times by 7 plus 7 minus 1 times by 3. Now I'm going to plug this into my calculator and see what this gives me. I won't do any algebra and stuff there just in case, because I was just suspicious of that answer pretty much. 112, no, that's correct. Did I do this bit right? No, that's 112, that's still correct. 13. Oh, okay, that's wrong. My mistake. So the previous stuff we just did there was correct. 16 plus 3 is not 18, it is 19. Then you add another 3, and that gives you 22. So 1, 2, 3, 4, 5, 6, and plus another 3 is 25. Okay, cool. Now if we add all those together, that should give me 112. So it's 7 plus 10 plus 13 plus 16 plus 19 plus 22 plus 25. Yeah, that's it. Okay, cool. So ignore that little blip there. I won't edit it out because that can actually happen. But yeah, that's correct. This, I was just double checking because that's a lot of fish, but yeah, good on you, Greg. Anyway, let's move on to the next question. Okay, so for an arithmetic sequence given here, find the number of terms and the sum of the terms. So we've actually been given pretty much a boundary, so we've got pretty much a pattern, but we've been given a blockade pretty much. So from here to here pretty much, so from -3 to 49. So we need to work out how many terms are here pretty much. So in other words, we know what the first term is and we can work out a difference, and we know what the n term is. So this 49 is your S of n, pretty much. You're trying to find out what that term is. Now, actually no, that isn't your S of n, sorry. That's your T of n. Okay. So your S of n would be the sum. That is your final term. Now, if you solve for that, you'll produce that index, and the index will tell you the number of terms, pretty much. So T of 1 is -3. The difference is going +4 each time, so the difference is +4. So T of n equals T of 1 plus n minus 1 times by d. So T of n equals -3 plus n minus 1 times by 4. So T of n equals 4 minus 7. So now you substitute in 49 here. So 49 equals 4n minus 7. So 49 plus 7 is going to be 56 equals 4n divided by 4. And let's see what that gives you. I'm pretty sure that's going to be 14. Yeah, n equals 14. So that means that's the 14th term. And now we're asking for the sum of the terms. So the number of terms is 14, and now we're asking for S of 14. So S of n is n on 2, twice the first term, plus n minus 1 times by d. You notice we're using a lot of this formula stuff still, even though it's the series part of it. It's all interlinked pretty much. I'm sorry. So S, your index is 14. So S of 14 is 14 over 2, twice the first term, which is, what do we say, negative 3. Good enough for me. Plus 14 minus 1 times by 4. Okay. So 7 multiplied by negative 6. Here you're going to have 13 times by 4. So what you're going to get is, 3 times by 4 is 12. 4 times by 1 is 4, plus 5 is 4 times by 1 is 4, plus 1 is 5. So 13 times by 4 is 52. So what we have here is 52 plus 52. 52 minus 6 is 46. Times by 7 will be your sum. So 46 times by 7. 6 times by 7 is 42. So 4 goes up here, 2 goes down there. 4 times by 7 is 28, plus 4 will be 32. So we're going to get 322. So your sum is 322. So if you add all those guys up together, you'll get 322, which sounds about right, because a lot of those are whole full numbers. And yeah, these terms here will be, like the three terms after 49 added together will be more than 100, so that makes a bit of sense. Righto, so let's go down to the next question. Also, if you have any questions about any questions I've covered in this video, leave some in the comments and I'll try my best to answer them. Last 2 questions for the video, and then yeah, we'll move on to geometric sequences and series, pretty much. So the sum of the first m terms of an arithmetic sequence with the first term -5 in common difference 4 is 600. Find m. So it's actually very similar to the one that we had just there. So S of m. So all they did is pretty much, alright, so instead of using this formula here, wherever there was an n, they just said m to be a bit cheeky, which is a bit ridiculous. So S of m is 600, and we're asked to find m, so the term that is. So we got the first term, and you got that difference pretty much, which is 4. So that's that sum. So in other words, plug in an m. So S of m is m over 2. 2 times by -5 plus m minus 1 times by 4. Substitute now this for that. So we get 660 equals m on 2. This will be minus 10. This will be plus 4m minus 4. And we can see we're going to get a quadratic expression here. Now I'm going to move that 2 up there because it's annoying me. So double that is going to be, oh, what will that be? 600 times by 2. Well, 600 times by 2 will be 1200. And then 60 times by 2 will be 120. So it'll be 1320. I think so. Alright, now we're going to distribute the m. So we get -10m plus 4m squared minus 4m. So we see we get a little quadratic equation here. Now the cool thing about this is we're only accepting positive answers because you can't have a negative term pretty much. You always start at 1 pretty much with a sequence. The first term, you can't have a negative term. So 4m squared minus 14m, and bring this guy over there, so you get minus 1320 equals 0. Now I'm going to divide everything by 4. I think that will work out. Actually, no, it won't because of this guy here, so we're just going to leave it like that. So remember what our quadratic equation is. So x equals -b plus or minus the square root of b squared minus 4 times a times c, all onto a when you have a quadratic expression that looks something like this. And as I explained in my previous video, I write my b's as capitals because my lowercase ones look like 6's. So straight off the back, we know what each term is. That is your a, that is your b, the -14, not just the 14, the negative as well, and that is your C pretty much. So let's rub this guy out. We don't need him anymore. If you want to copy that down, just rewind the video. Okay, so in other words, M is equal to negative 14 plus or minus the square root of negative 14 squared minus 4 times by 4 times by negative 1320 all over 2 times 4. Okay, so M equals, now this is going to be positive 14 plus or minus 14 times 14. That is a bit ridiculous to work out, but we can do that anyway. 16, 5, 4, and 1. So 196. So square root of 196. And then you got 1320 times by 16. Okay, I'll need a bit of room for that one there. Okay, so multiply 6 by 0 is 0. 6 by 2 is 12, so 1 and then 2. 6 times by 3 is 18 plus 1 is 19. Carry the 1. 6 times by 1 is 6 plus 7 plus 1 is 7. Boom, boom. 0, 2, 3, 1. So 132 times over 16. I'm just making sure I get it right in the calculator as well, just in case I do stuff anything up. 1, carry the 1. So you're going to get 1, carry 1, 2. Yeah, that's it. Okay, cool. So moving this down here. Now you could be asked to just do this without non-calc, so that's why I'm showing the multiplication tables. So what we have is pretty much positive 2. Oh, that is distorted. I don't know what happened there. So 196 plus 21120 over 8. Okay. Realistically, you would shove this into a calculator now because those numbers are ridiculous. So I'm going to plug in that little bit there. So this bit turns into 146. I don't know. Oh, what's that in the PowerPoint? It's updating. Okay, so that bit there, so this blue bit, including the square root, turns into 146. So your M is going to be 14 plus or minus 146 over 8. So that means you've got pretty much two answers. So your two answers are, well, M equals 14 plus 146 over 8, or 14 minus 146 over 8. Now, it won't be this term because that'll be negative, so it's going to be this term. So 14 plus 146 divided by 8 gives you M equals 20. So it is M equals 20. That's the 20th term. So in other words, S of 20 is 660. Ta-da! Alright, let's move on to the final question of the video. So, 15. Liz has to proofread 500 pages of a new novel. She plans to read 30 pages on the first day and to increase the number of pages she reads by 5 each day. So pretty much it's going 30, 35, 40. That is a lot of pages to read, but she'll actually get it done if she increases those pages. That's if she's actually consistent as well. How many days will it take her to complete the proofreading? So in other words, well, if there's 500 pages, we're looking pretty much when is the sum of all the pages going to be 500. So you agree here in the first 2 days she's going to read 65 pages plus 40, so she's read 105 in 3 days. So it's not going to be too long, honestly, but the sum of the pages will be 500 pretty much. That's what we're asking for. So we're looking for this n straight away. So we know our first term, it's 30, and we know our difference, it's 5. So S of n is n over 2, 2 times the first term plus n minus 1 times by d. So 500 equals n over 2, 2 times by 30 plus n minus 1 times by 5. Okay, we're going to get another quadratic. How good? I'm joking. It's ridiculous. Okay, move that 2 up there, so we have 1000 equals n, and then we're going to get 60, and then we're going to get plus 5n minus 5. So if you don't know what I just did there, this was my 60, and then I just distributed the 5 there. Okay, righto. So 1000 equals, well, n times by 5n plus 55. So in other words, 5n squared plus 55n minus 1000 equals 0. I know that's all going to be a multiple of 5, so divide everything by 5 because I can. So what we're going to get is n squared plus 11n, and 1000 divided by 5, I'm not sure what that is, minus 200. That's it. Okay, cool. So now we solve this quadratic pretty much. She has to read. Okay. So you've got a quadratic looking like this, and you've got your quadratic formula, which we wrote down before, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So n is going to be negative 11 plus or minus the square root of 11 squared minus 4 times by 1 times by negative 200, all on 2 times 1. So I'm going to evaluate the square root because I don't want that being ridiculous again, which it will be. So the square root of 11 all squared minus 4 times by 1 times by negative 200 gives me the square root of 921, so not a clean number, plus or minus 11, negative 11 on 2. So for context, this number is approximately 30.34 using my calculator. Okay, so what do we do? Negative 11, so you're going to use the positive one because you can't have a negative index, so you get rid of this negative sign. So you're going to have 30.34 minus 11 divided by 2. So 30.34 minus 11 divided by 2 is going to be 9.67. Now, if n has to be discrete, so it would take her roughly 10 days pretty much, because you can't have 9.6 of a day. Now we've got to continue reading the question. She only has 5 days to complete the task, therefore decides to read 50 pages on the first day and then increase the number by adding a constant amount each day. Okay, so that's pretty much the second part to the question. So for the first part, it would take her 10 days to do that, but she wants to complete it in 5 days. So this is now a follow-up for question B, because this is new information. So it doesn't apply to A because it's written after A. So all that working is just for A still. Let's rub this stuff out because we don't need it anymore. Alright, so now she's changed it. Now she needs 5 days to complete the task. So obviously she's gonna pretty much increase her game of like reading. Because 10 days, she pretty much needs to half that time straight away. So now her first term is 50 pages, so T of 1 is 50, and plans to increase the number she reads by a constant amount each day. So we don't know what that is. By how many should she increase the number of pages if she reads each day if she is to meet her deadlines? Okay, so pretty much she has to complete it in 5 days. She's starting at 50 pages, and we've got to tell her how much she needs to increase her pages each day in order to meet that deadline. So we know we pretty much need, alright, S of pretty much, what was our previous working? S of 5 to be pretty much 500 pages straight away. So S of n is n on 2 multiplied by 2 times the first term plus n minus 1 times by d. So what this pretty much means is, alright, her deadline is 5 pages, 5 days, but she has to read 500 pages of a novel. So what that's saying is pretty much, alright, in the next 5 days, the total number of pages she needs to read is 500 because S means sum. So she's going to go 50, and then she's going to increase by a certain amount, but we don't know what that amount is, but we can solve for it using this expression bit here, because we know she has to finish in 5 days, and there's a total of 500 pages. So we replace the index with 5, and this with S of 5, which is 500. So 500 equals 5 on 2 times the first term, which is 50, plus 5 minus 1 times by d. And now we've got to just solve for d straight away, and that'll be the answer to b. So let's move that up real quick. I don't know how long this video is. It's going to be very long, but we're almost there. So move that 2 up there, so we get 1,000 equals 5 times by 100 plus 4d. 1,000 divided by 5 is going to be 200, so 200 equals 100 plus 4d, so 100 equals 4d divided by 4, so d is 50. So in other words, she reads 50 pages on the first day. She needs to increase that by 50, so on the second day she needs to read 100 pages, then 150, then 200, and then so on and so forth, and she will meet her deadline pretty much. Okay? And that is the answer to the final question I've chosen. Now, that was a very long video. I hopefully will credit to anyone that made it through that whole thing, but you'll probably watch it in snippets, honestly, like probably at school and stuff. But I hope you enjoyed this video. There'll be more stuff coming soon on geometric sequences. Alright, see you in the next one.